Hello, I am Paolo Bassi, Vice President of Research and Development for SolidWorks.
And I'm Gregory Mark, the founder of MarkForged, and we have the world's first 3D printer that prints carbon fiber. And Gian Paolo is here to talk with us about how we would use this.
Okay, very good. So I was literally blown away by your product, Greg. It's a world first carbon fiber printer.
Yes.
Am I right? Okay. So what kind of product can you print?
So I'll tell you a little bit about the materials.
Okay.
So we have one print head that prints in nylon, like a traditional FDM printer, and that comes out of the first head. And we have this second new head, which is in carbon fiber. It makes parts that are a whole bunch stiffer.
Okay, this is very flexible. Okay, nylon, you said,
Yes.
and this is carbon. Oh wow! So the big difference here is strength. You can easily bend this, and this is super strong. So the key to your invention is mixing these two materials
Yes.
to do high performance products.
Absolutely.
Tell us about this.
So let's say, for example, you wanted to design a part for a race car, right? You would first design the part in SolidWorks, and then you would print it out on the printer in the traditional plastic mode, and you would test and see that the fit is correct.
Okay, let's see. So what you're saying is that this is the conceptual
That's
shape.
the conceptual
Okay.
phase.
So you basically check
Make sure
form
that it
and
fits.
fit. Okay.
Yes.
It's not about performance, but
Yeah.
it's very light. It's nylon. I guess low cost.
Low cost.
All right. So you can print many of those.
Yes.
Until you get the shape right.
Yes.
Is that what you do?
And once you get the shape right, then you can add the layers in the same printer with now the second print head. You add the layers of composites. So now you get a part that is 10 times stiffer, and it has both the fit and the function. So you can actually put this on your Ferrari and take it around the track.
All right. You know, I'm very picky about the equipment of my Ferrari. So this must really be high performance. So this is the key to your invention. So you can lay out layers of carbon fiber.
Yes.
And you can alternate it to honeycomb type of layout done with nylon.
Yes.
In order to have, to save on material, and also to put the fibers in strategic areas where the stress goes.
Yes.
So this is incredibly strong, very stiff, as opposed to this. But again, this is just for the conceptual phase.
So what we have here is a display that shows the process of building that part. So we put down that first layer of nylon, and that lets you have a nice smooth surface. So when you put it on the Ferrari, it doesn't scratch the paint, which is nice.
You better not.
And then we move up and we lay down this continuous strand of carbon fiber to give it, we put it on the bottom to give it that high strength. We fill in the middle with honeycomb to keep the weight down and the cost down. And then we put another layer of this composite toward the top, and we top it off with some more nylon. So the entire part is encased in nylon, which gives it a nice, smooth, gentle surface, while the inside is this strong composite.
Okay, but Greg, I have an engineering background, so when I was at school, this type of parts were only for very high-end applications. Why? Because first of all, it's not easy to define a layout that is optimal, but also the manufacturing is
Yes.
complicated. And by the way, if I well remember, these things needed curing,
Yes.
which is complicated, and people don't usually do that. They, for regular applications, they use aluminum. So how do you solve these type of problems?
So as you mentioned, in the traditional method of making composite parts, you would have a mold and you would by hand lay the fabric in there, and then you would cure it and then trim it, make a top part, make a bottom part, glue them together, and then cure it and trim it again. And what we have here is, in the print head, the print head has a thermoplastic matrix inside the carbon fiber that when you print it, it cures as it prints, or it more accurately, it cools down as it prints, and it bonds to the layers below it.
Okay, so when it comes out from your machine, it's ready to go.
It's done.
Okay, so what you are saying is that you can extend the applicability of this type of composite to a much wider set of applications.
Yes, and one of the things we did is we took this idea of 3D printing and the movement of this 3D print head, and we now changed it to adapt it to turn it into a layup process for composites. So we took that hand labor part of laying the composites in the mold, and we automated it with a 3D printer.
Okay, but You know, Greg, one thing that I noticed is that this is fantastic. These parts are amazing, but your machine is very beautiful. So it's not only about the function of what is coming out, but the machine itself is such a beauty. It seems like an Apple product, right?
Well, thank you. We wanted to make this something that the customer would enjoy using, so that they had a good experience. You know, you put it on your desk, it looks pretty next to your laptop, and that when you interact with it, you can not only print these strong parts, but you enjoy using it.
Oh, wonderful. So it took like 8 months, if I well remember, we were talking about this, to go in pre-production.
Yes.
So you must have talked to somebody, some early adopters. What were they trying to do with your machine?
So one of the first applications is prosthetics. And prosthetics is a great application because you start with, you have to make this part that fits onto the human body. So as we had Hugh Hurd showing us today or 2 days ago at SolidWorks, it takes a lot of different iterations to get that part to fit well onto your arm or to your leg. And so you would go through those iterations with nylon.
Okay.
And then once you have it so it fits comfortably, you would now add the composite. So you have a structural part that you can now use and you can walk with.
So it will be easier to create prosthetics for people that need them. So it's not only about the performance of my Ferrari, it's also about making everybody's life easier and better. Right?
Yes, and one of the other exciting applications is biomedical. So people are right now starting to print these bones out of nylon.
Okay.
But the bones are flexible.
Of course.
But your bones are stiff. So what we can...
It's stiffer.
It's stiffer and stiffer. You need to drink more orange juice.
Oh, come on, juice. That's for kids.
More red wine then.
Yes.
So when you now make this bone, now that you have this second print head, you can make the outside out of the nylon. So you can make a custom shape tailored to you, right? And it's nice and smooth, so it has a smooth wear surface inside the socket. But you can reinforce it with composite, so you can match that stiffness of the bone to your actual bone.
Okay.
Which now gives you a part that you can, or part of your body that you can use.
Okay, so high performance parts, body parts, improving everybody's life, a beautiful machine. I truly think this is a revolution. Congratulations.
Thanks, Jean-Paul.
A production of EBD Media.